Hi everyone, my name is Iga Szczesniak. I have been working at the JuliaEO Center for the past 2 years as a project developer, but now I work at the European Space Agency as a space innovation engineer in headquarters in Paris. Today at JuliaEO, I wanted to share with you a real-time alert system that I have developed fully in Julia over the last summer. So the alert system is for vineyards monitoring using the data from the Internet of Things sensors that we have installed in 4 vineyards on this island in Terceira. Yeah, so the system is using meteorological data from these IoT devices, and later there is a model of a disease that attacks healthy wines. It's called downy mildew. It's a fungal disease that attacks healthy wines and is driven by the weather. So we have developed a model that calculates the risk of the infection of this disease. And it was possible to use only one language for the model itself and the front end as well. I'm going to share the results just right away. Just wanted to say that in general, people do not care about data and algorithms, but rather about knowledge and information. So this is really useful skill to know how to do a proper data visualization or a dashboard or this kind of real-time data application. And it's worth to know how to do this in Julia and the available tools and frameworks and also their pros and cons. So this is how the dashboard looks like. It has 3 main parts. First of all, there is a map of the locations of the sensors. Then there is a dashboard displaying meteorological data, such as temperature, humidity, precipitation, and so on. And finally, there is a model of the primary infection of downy mildew, which we could filter by sensor or vineyard in this respect. So the idea is that when the certain weather conditions are met, in this case is 10 degrees of Celsius of temperature and 10 millimeters of accumulated rainfall within 2 days in a row, there is a risk of the infection of this disease, downy mildew. It's a primary infection, the stage of the disease. So we have calculated this in Julia. Also tested various rainfall thresholds because of the uncertain weather conditions on this island. Some wine producers reported that they follow the rule that 10 millimeters of rainfall is relevant in their property. Some of them were saying, oh no, 7 is that what we are looking at, or 5. So we have developed 3 scenarios. And last but not least, this model is only relevant when the plant itself has 10 centimeters. So the model should be run from September till March every year. Other than that, the plant is not high enough. So the sensor send hourly data to the JuliaEO Center server, and then I download the data and do all these visualization steps. All of this has been developed in the scope of Vineyarda Terceira project that Jean mentioned previously. So the objectives of the project were to create real-time monitoring of the vineyards in Terceira Island and to develop data visualization and automated alert system for this disease downy mildew. also to give the wine producers the opportunity to use modern tools and take more informed decisions based on first sight of the service, which they didn't have until now. The SOFI system is based on the LoRaWAN communication protocol. So the Internet of Things network that Joan mentioned previously is also based on this LoRaWAN communication protocol, but the SOFI sensors are slightly different. They are powered by not batteries, but by the solar panels, and they measure more things, basically. The other network measures only temperature and humidity, while the SOFIs measure also precipitation, wind speed, wind direction, and solar radiation. So more things to measure. Here is more pictures of the SOFI sensors and how did we deploy them. So as you can see, this is a small device powered by the solar panels, and we place them in Biskojtos. It's a village in the northern side of the island where people typically grow their wines, and this is very characteristic. They grow the wines inside the fences made by the rocks, as on the last peak. So in this pilot project participated 4 vineyards. However, I think I forgot to mention, but the device itself is low cost, is less than 100 euros per each. So I believe this solution can scale up for other vineyards, for other islands. I mean, for example, Pico Island, that is really known for growing wines, or Portugal mainland, where there is the Douro Valley, or even other countries or wine regions around the world, like South Africa, for example. I believe we could track different diseases if we know any specific information, how they develop. So this is a pilot project on how this prototype could work using Julia. Why did I choose Julia for it? So in general, Julia is good for working with matrices and vectors, and we know that geospatial data are made of those. It has a common an ecosystem for common geospatial operations, so it's fine as well. And Julia is a modern language, and it has a built-in package manager called REPL, which is easier for me to manage the project environment, for example, and there is no need to use any external software such as Anaconda, for example. As mentioned before, Julia solves 2 language problems, so it could give us the really high performance, but still keeps the user-friendly syntax, so it is easier to develop in. And last but not least, the user-friendly syntax that is based on mathematics, and this is really a good thing when you need to do some calculations, because it's I found it easier compared to other languages. For my project, I have used Dash.jl framework. It's a Julia framework for building interactive web-based data applications, and eliminates the need of switching between different programming languages or tools. So there are other frameworks available. There's not only Dash in Julia, there is Bonito.jl. For those of you who know Maki, that's the natural choice. And there is also Genie. I didn't choose Genie because it was commercial, and I realized they go rather in this direction, so I wanted to keep in Dash. I didn't choose Bonito because at the time I realized maybe it was not enough documentation. So I decided to go for Dash.jl, and I really like the experience. The key features of Dash is that you can create the visualizations like all kinds of charts and plots and maps and tables in it. It enables real-time data updates. So it is important when creating a real-time alert system, for example. You can be also creative with the layout. It's not predefined for you, so it can really look like whatever you want to. And it enables interactive elements. This is also important to, for example, avoid the oversaturation by data and make your plots clean and nice for the end user. How did I start working on this? First of all, I look at the Dash for Julia documentation. They have quite a nice documentation, and they have many examples, including the minimal Dash app. So that's the thing that you can run on your local server and have the sense of how does it work, and then add the things on the top of it. So with this guide, I would say, it's really straightforward to develop your own data application or alert system. And I attach here the link if you're interested to see it afterwards. Some visual elements of Dash.jl that I believe everyone at some point will use when developing the data app or alert system are graphs. So in Dash, we could create really nice interactive and what's important, responsive graphs. It's built on the top of Plotly.js, and it added, for now supports over 35 graph types, including more fancy scientific plots as well. So you can choose between different ones. Other element that I found useful is a drop-down list. So it's really useful when you want to select your data by a certain variable or parameter or column. In my case, it was sensor number, so the vineyard number itself, so that the wine producer can really look at his own data, his own property. Another thing commonly used when creating a dashboard is a slider. It's useful when displaying a range of data or a time series of data and in general handling dates. And this, I must say, I didn't really like in Dash.jl. I mean, handling the dates. So the numerical slider was kind of okay, but the date slider, I didn't really like the experience. So in the end, I decided to have the buttons with the time range in my dashboard instead of having this slider. So you might take a look at another frameworks like Bonito or Genie. Maybe they have a nicer slider for dates. Another thing that is useful is for geospatial people, I believe, is a support for Mapbox. So to bring location technology to your data application. We use it to have a map background behind the data points, for example, or coordinates. So in my project, I have used the satellite view and the streets view, and it's possible when using Dash at the moment. Another step was calculating the 10-10 model. I did it in Julia as well, so that was really convenient that I didn't have to switch between different languages or tools. I just really had everything in one project and keep it clean. So that's how it at the moment looks like. The rainfall and the temperature thresholds are displayed, and then you can see respectively the alert if there is a risk of the infection of this disease downy mildew. So the farmers can really take a look if they should take any preventive measures to their wines if they want to. So to create this thing, we had to, first of all, talk with the stakeholders, the Smart Farm Collab organization, which is farmer organization, and the wine producers to understand their needs and what they want to really extract from data and what information they are interested in. Then I designed the dashboard layout, so how those all elements are placed on the web page. Afterwards, I created the graphs and visualizations to display the weather data. And afterwards, I implemented the the model of the risk of primary infection. Add interactive elements, so all these drop-down lists, buttons, etc. And finally, we deploy it on the web. If you're curious to see the dashboard live, the first QR code is here. The second one is for the code. I must say that the dashboard better looks like on the laptop or a bigger screen than the phone, but that's maybe not the best in Dash, that it doesn't look very pretty on the phone on the small screen. Other than that, we use Julia for validation of the measurements from Internet of Things network. It's a network of around 50 sensors here on the island. So we have a paper about detecting fungus spores in the fields where you can find the results of this sensor validation. This also has been made in Julia. So my final thoughts is that Dash can be a way to go to build interactive and web-based dashboards, but you may take a look at other alternatives like Bonito or Genie, because they might work better for you. But I found, in general, my experience with Dash really cool. Yeah, Julia is a good choice for fast prototyping, and especially if you want to test a solution that is coming from science and from research, because it's easy to write calculations and you can keep only one programming language. Also, Julia has a mature package ecosystem to build this kind of stuff in various fields, not only geospatial, of course. And before I finish, I wanted to share with you a little bit of my current work at the European Space Agency, because I think like some of these things might be relevant for you as well. Right now I work on the Discovery and Preparation program at the European Space Agency, and this is a main program for finding the novel technological solutions for space at ESA and preparing the agency for the future. So we run this open call where everyone can submit their proposal, and then it will be evaluated. And then we evaluate all of those research proposals and give the funding to the ones that we see a lot of potential and also novelty. So the idea is that we really take a look at the novel solutions, even of low technology readiness level, but the goal is that those solutions needs to be novel. So at the moment, we have 3 implementation schemes for studies, early technology development, and co-sponsor research. Studies and early technology development are up to 12 months, when co-sponsor research could be more, because it could be also a PhD project as well. So you are really welcome to submit your proposals as long as your idea is novel and related to space technology. We don't necessarily, we of course care about Earth observation, but also look at all bunch of different space technologies, from quantum to of course, artificial intelligence, space habitats, and in situ resource utilization, and biotechnology and other technologies. So it's really not only about Earth observation, but very different space technologies. So if you see yourself applying, you can let me know, and yeah, I might help you as well. Yeah.
Is this open to the US?
Oh yeah, it's open for all ESA member states, but it means that the entity needs to be registered in ESA member state, but the person could be from the US. So the entity of the entity who is applying needs to be from ESA member state, but then the researchers could be international.
They can spend the money in the US?
Yes, as long as the entity is registered in Europe, in the member states. Yeah. Also, the program is under ESA basic activities, and it means that all member states contribute to its budget, and it's really low barrier to enter, because other programs at ESA are rather that you need to have a national delegate to apply to them. So it's really low barrier to enter, and it's really for everyone. Yeah, like, I really encourage you to apply. So until now, we had around 3,575 ideas submitted. So this is for the open call. But we also launch thematic campaigns about different technologies, like swarms of CubeSats, or recently we launched one for large space structures and maintenance in space. So it could be either some thematic campaign or just open call. And also in my team, we use data science and AI to kind of extract information from all of these project proposals and cluster them automatically, for example, or extract what are the trends at the moment in the submitted proposals, or also to figure out what is missing and not yet addressed at ESA that we might want to take a look in the future. So we use data science to kind of provide more insights of the program, either to the higher management or ESA member states and their delegates. This is the Open Discover Ideas channel, where you can submit your ideas and your proposals. I'm going to share with you the presentation afterwards, so you will have the QR codes in one place. But this is how does it look like. Yeah, and the process is straightforward. You just submit the proposal to the web page, and then ESA experts evaluate it, and it may result in a contract. And the funding depends on the type of contract that we agree on. So, as I mentioned, this program is for low readiness levels of technologies. And if the technology is a higher readiness level, then it is better to apply to other technology programs at ESA, like GSTP or InCubed for Earth observation, or ARTES for navigation, and the other programs. So if you really want to test a solution, then OZIP and discover and preparation is a way to go. Other part of our team, of our work, is preparation of future missions, and we work on preparation of the early phases of space missions. I mean pre-phase A, phase A, and phase B1. And around only in 1 year, we take a look at 30 different missions. We also found concurrent design facilities, which are special meetings if we want to discuss a mission concept that is not yet proposed to the member states. So a bunch of engineers and different working groups are closed in one room for the entire day, and they discuss different trade-offs of the mission and whether it makes sense to continue with its development. So this year we had the concurrent design facility of Aurora C mission, that is a swarm of satellites for monitoring of the northern lights. We look at the pre-phase A missions phases and phase A. So for example, Sentinel-2 and Sentinel-3 next generation, we found these kind of studies. Last but not least, we run the Visiting Researcher program, and it enables you to use ESA facilities and exchange knowledge with ESA experts for 1 year. And at the moment we have around 50 researchers in the program, and this is also an open call, so you can register all year round. At the end, I attach the useful links to the web pages that you may explore. So OZIP is the page that you might want to send your proposal, or if you want to view other similar proposals that have been submitted to the program, you can go to Activities portal or the Nebula portal. Thank you for today. If you have any questions, I can take them now or later at the coffee breaks, and I will be here all week. Yeah.
Yeah, I'm just wondering how much of an interest is there at ESA for Julia? You know, how many colleagues of yours are using?
Yeah, to be honest, none of my colleagues are using, and yeah, in my team we use Python at the moment, but I'm trying to maybe like use it for some dashboard preparation. Yeah, but as far as I know, like in my team, there is no people using Julia. Maybe in other directorates, yes, but I'm not aware of.
So I guess it's very useful if we send proposals to you that are emphasizing Julia, and we might have you as a reviewer as part of the case.
Well, then I would need to, like, there will be like a conflict of interest between us, so then I'm excluded from the evaluation.
Oh, I see.
Yeah. Yeah.
I was going to ask, so one of the cool things about DashJL is that it kind of democratizes the ability for someone to build a GUI without needing the knowledge at hand to kind of do it from scratch. And typically in my workflows, we work with large data. So when using DashJL, do you notice any kind of performance hits when building GUIs for large data sets, or is DashJL usually the kind of sweet spot for its use is more in the smaller data regime?
Well, I didn't use it for a very, very large data set, so I don't know about this hands-on. in my data set, it was just rather fast. I never remember waiting to have any results, but at the bigger data sets, I'm not sure.
So no more questions, lunchtime?
Yeah.